Hey math kids, today we are going to talk about functional notation. Um, and yeah, so I'm almost sure you've learned this in a class before this, so this should be pretty much review. But, um, so f of x equals y. So if we write it using f of x, then we call it functional notation. And that's really just the gist of it. Now, your book uses kind of a really strange notation. Try not to get freaked out by it. So it looks like this. Now, all this weird notation means this entire piece right here is just f of x equals, and then you just have your function. Okay? So it's weird notation. You never have to write it in this notation. Just know that if you see it that way, like on an IB test or in your book, then that's what it means. So the first thing is they want us to find f of 5. So that means is, since we replaced x with 5, we're going to replace these x's with 5's. Okay, so just follow PEMDAS. So we need to do exponents first. So that's 25. Now we can do multiplication, so that's 50 minus 15. And then that is 35. So f of 5 equals 35. Okay? Now, for the same function, they want us to do f of negative 4. So once again, we're just going to replace all the x's with negative 4's. Okay, so we square that. So we get 2 times 16. Now we multiply. And 44. So f of negative 4 is 44. Okay, hopefully that's not too bad. Okay, the next one gives us f of x is equal to 5 minus x squared. And they want us to find f of negative x. So all we're going to do is replace all the x's with negative x's, and especially on one like this, I highly suggest using parentheses like that. There's high potential on this one to make a sign error, and so try to just take your time on that. So negative x squared is going to give us positive x squared. I know that's confusing, but then this negative is this negative. Okay, now these negatives are going to become a positive, so it's 5 plus x minus x squared. And that's equal to f of negative x. So 5 plus x minus x squared. All right, that's kind of weird, huh? Okay, so f of x plus 2 for the same yellow function up here. So once again, use parentheses. I'm replacing all these x's with x plus 2's. All right, so I'm going to think of this as x plus 2 times x plus 2 and distribute. So I still have this negative, but then I'm going to get x squared plus 2x plus 2x plus 4. All right, continue with that. So I'm going to just get x squared plus 4x plus 4. I just combine like terms. Okay, now I'm going to distribute this negative, and I'm going to distribute this negative. So 5 minus x minus 2 minus x squared minus 4x minus 4. And then combine like terms. So we got these two things. So that's going to be a 3. Oh, whoops. And then this negative 4. So that's actually negative 1. And then we have negative 4x, negative x, so that's negative 5x. And then we just have our negative x squared. All right. And so this was our f of x plus 2 was equal to this thing. All right. Now going back up here. Once again, looking at this yellow function, we're asked to find f of x minus 1 minus 5. Alright, that notation's a little scary, but what we do first is we plug in x minus 1 for all the x's. And then we just subtract 5 at the end. Okay, so that subtract 5 actually makes that a little bit easier because those two just cancel. Now I'm going to square this. So I'm going to think of it as x minus 1 times x minus 1. So I have my negative sign, and I get x squared minus x plus 1. And then I still have my negative x minus 1, like that. Okay, so combining like terms right there, I get negative 2x. And then distribute the negative. So negative x squared plus 2x minus 1. Distribute the negative here. Negative x plus 1. Alright, so we get negative x squared. This and this makes positive x. And then 1 and negative 1. That's it. Okay. And so this is equal to f of x minus 1 minus 5. Alright, that was kind of crazy, but hopefully you followed that. If you need additional help, please come to Math Lab. Until then, calculator.